Okay, so today we're going to talk about composition of inverses. And what composition of inverses does is it actually checks if two functions are inverses of each other. But before we start that and talk about how it works or what we would need to do, let's just think of if we composed inverses and see what should happen. Well, what should happen is if you take a function f and you take a function f inverse, is these are opposites of each other. So f is an opposite of f inverse. So they actually cancel, and you're just left with what is on the inside, which in this case would be x. If I did this, we would be left with 3. Because again, an function and its inverse should cancel, and then you'll just be left with your input. We're going to see how that works with a couple of examples. Okay, so we're going to check if f of x and g of x are inverses of each other. And again, if we do f of g of x, if these things are really inverses, f and g will cancel, and our answer will be f. But let's actually go through and check and see what would happen. So we would take the function g and plug it into x, and we would get 2 times x minus 3 over 2 plus 3. And if we did this, well, timesing by 2 and dividing by 2, that would cancel out. I would have x minus 3 plus 3, and minus 3 and plus 3 would cancel out, and we would get what we expected. We do have to, if you do it one way, to actually prove it's an inverse, we also would have to check it the other way. So we'd also have to see if g of f of x equaled x. So we do have to check it the other way, which means that now f would go into g, which means that I would have 2x plus 3 minus 3 over 2, because again I just replace this x with this over here. And then we'd go through and solve. Well, the 3's would cancel out. I'd have 2x over 2, and 2 divided by 2, well, x is really x. Okay, let's do one more example. Again, for this one, we have to show that f of x, f of g of x equals x, and g of f of x equals x. So that's what we're trying to show. Let's see if we can show that. So to start out, I got to take this and plug it in for that x. That would give me 4 times x plus 3 over 4 minus 3. Again, we can see what's going to happen. Those 4's are going to cancel. Those 3's are going to cancel. And it does work out. If we do the other way around, we would have this going into here. So that would be 4x minus 3 plus 3 over 4. Those would cancel, and I would get x. So again, you're just trying to check to see if this inside actually does equal, and it does, because this function canceled with each other, and we just got our inside value. Let's see one where they don't cancel. Now if you look at these things, they do not look like inverses. They don't look like opposites of each other. So they probably are not but we can still check and see what would happen. So we have f of g of x, and again we're hoping to get x, but we might not, and we probably will not this time. We'll take this and plug it in right there. That's going to give me 2 times x minus 4 plus 3. That's going to give me 2x minus 8 plus 3, which would give me 2x minus 5. And that is not x, so these are not inverses of each other. So in the case where you compose two things that aren't inverses, it just works like normal composition, like we've been working on this whole entire week. So if you have any questions, let me know.